All right, guys, welcome back. We're going to go through our last type of question, all with our tests for parallelograms again, but this time it's going to be a graphing question. So, graph the following figure and determine is it a parallelogram or not. Explain why or why not. So, the first thing we're going to do is we're going to graph it. If you don't have graph paper at home and you want to see the shapes, you can follow my other little tutorial video on GeoGebra, or you can just sketch it as best you can. For right now, it's going to be okay. As we get into some of the more detailed graphing, you're going to want to try and figure out either using GeoGebra or try and find some graph paper at home. GeoGebra is super, super easy. Again, if you have any questions, feel free to ask us a question on it, and we'd be happy to point you in the right direction. So I have a piece of graph paper here because then we can do all of our work right next to it. So I'm going to graph these points. A is at -4, 2. B is at 2, 2. C is at -2, -1. And then D is at 4, 1. Oh, and actually I see that the naming is messed up. It should always go around the perimeter. You shouldn't be cutting over. Sorry about that typo in here, but we're going to know that it's a quadrilateral polygon here, so I don't want to cut through the center of it because then it wouldn't be a polygon anymore. So we're going to look at it named poorly here. Sorry about that. Or we could name it quadrilateral A, B, D, C to kind of go along with that. All right, so we want to determine if it's a parallelogram or not. So let's go back and look at our tests for parallelograms. These are the ones that we took notes on in the last video. Let's look at it in a graphing standpoint. If we are going to be graphing, what is it going to look like? Okay, well, if it would say both sets of opposite sides are parallel, oh, that would be parallel goes looking at the slopes. The slopes would be the same. Okay, so then we would have same slopes. Then we'd have to do 4 slopes, I should say. Actually, as we're going back to that test, we'd have to do 4 slopes because we need to check both of the opposite ones. Then the next one, oh, opposite sides are congruent. Oh, that would be same distances. That would end up being using our distance formula. All right, and going back and checking 4 distances to make sure all of the opposite sides have the same distance. So that would be 4 times using the distance formula over. The next one is both sets of opposite angles are congruent. There's really no way for us to do that one on the graphing, so that's when it's going to be not possible to check out graphing-wise, but we're going to have enough to pick from. Then the next one is the diagonals bisect each other. Oh, if the diagonals bisect each other, they always meet together at this one point, which is going to be our midpoints. So midpoints are the same. So that would actually end up being only 2 midpoints that we would end up finding. All right, we'd have to find the midpoints here and find the midpoints here. And that would tell me if it's a parallelogram or not. And then finally, the last one set is both parallel and congruent. So we would be looking at one set with both same slopes and same distance. So when I look at all 4 of these, we want to try and pick the easiest way to end up doing it. There obviously is no wrong way. You can choose whatever one you want. But if I would do slopes, I would have to do the slope formula, which is going to be 4 times over. Okay. If I would do same distance, I want the opposite sides, so I would have to check all 4 sides. So that would be doing the distance formula 4 times over. With number 4, I want the diagonals to bisect each other, so I would be doing the midpoints. And since there's only 2 diagonals, I would only have to do the midpoint formula twice. And then finally, the last one, if I want to have one set having the both same slopes and same distance, I would have to do 2 slopes and 2 distances, which is going to end up being 4 sets over. So mathematically, I think the easiest one is going to be checking if the diagonals bisect each other. So that's the one that I'm going to pick on this next one. And I know that I want to try and find that my midpoints are going to be the same on these diagonals. So I'm going to go ahead and connect my diagonals. And I want to see if they end up having the same midpoint. So you're going to have to go back and look over all of those formulas. I will put a little formula sheet out there for you for today so that you can check how to find slope, how to find distance, how to find midpoint, and use those to help you going forward. But for right now, the midpoint formula, remember, we are going to add our x's together and divide by 2, and add our y's together and divide by 2. So I'll know that this is a parallelogram if the midpoints of the diagonals are going to end up being the same. So this is where it's going to be a little bit tricky. You got to make sure you're looking at the actual diagonals. So the diagonal, the first one is going to be AD. So I'm just going to keep my work nice and organized here. AD midpoint. And the AD midpoint, I'm going to add up my x's. So that's going to be -4 plus 4 divided by 2. And add up my y's, which is going to be 2 plus a -1 divided by 2. So -4 plus 4 is going to give me 0 over 2. Here I'm going to have +1 over 2. So I end up with a final midpoint of 0, 1/2. So for this to be a parallelogram, when I look at CB, my other diagonal, it needs to have the same midpoint. So I'm going to go CB midpoint. CB's midpoint is going to be 2 plus a -2 divided by 2, and then 2 plus a -1 divided by 2. So it's going to give me 0 over 2, and then 2 plus a -1 is going to give me 1 over 2. So that midpoint is the same. So I know my midpoints are the same. So determine if this figure is a parallelogram. It is a parallelogram because, now I'm not going to say because my midpoints are the same. I'm going to go back to those tests that we did. And what was the test that this one had? Oh, if the diagonals bisect each other, then the quadrilateral will be a parallelogram. So as I go back here, it is a parallelogram because the diagonals bisect each other. Perfect. Make sure you have some reasoning. With these, all your reasonings, you're going to end up wanting to use the vocabulary from the test, no matter which one you end up deciding to do. Okay? And again, like I said before, it doesn't matter which one you want to do. If you want to practice doing it with the slopes, practice doing it with the distance formula. It doesn't matter which test you want to run. Just make sure you have the correct supporting math to back it up. Okay. Let us know if you have any questions.